Okay, 8.1 is the law of sines. So you guys are going to use the law of sines to solve oblique triangles. We'll also find the area of oblique triangles and hopefully do some real world problems. We are going to look at this special case right here, which is angle side side. You learned a little bit about in geometry, and that's going to be the trickiest part. So we'll get there in a second. All right, so we're going to have these four cases. If we have two angles in any side, so if we have angle, angle, side, or angle, side, angle, if you remember, those were geometry theorems for triangle congruence. So the law of sines is going to work just fine here. We're not going to have to worry about anything. Okay. If we have two sides and the angle opposite one of them, so we have side, side, angle. If you remember, that was not a geometry congruence theorem, so we're going to run into some issues with this one. Okay. If I give you three sides, you're not going to have any issues because that was a triangle congruence theorem. If you have two sides and an included angle, that's once again a triangle congruence theorem, so you'll be just fine. Okay. The only one that we're going to have issues with is number 2. All right, so here's the law of sines. I usually write it the other way around. I usually write it the sine of A over A, but it doesn't matter as long as you reciprocate each one of these. What it is the ratio of the sine of an angle to its opposite side. So all of these, hold true. You can even do sine of C over C. So it works for acute triangles. It works for obtuse triangles. If I have the sine of this angle A, for example, divided by its opposite side, that's going to be equal to the sine of angle B over its opposite side. So here's an example then. Let's take a look at this triangle, and we're told that C is an obtuse angle 102. We're told that B is 29 and that side B is 28. We want to find the remaining angles and the remaining sides. The first thing we can do is take 180 and subtract these two right here to find the third angle here. If we do 180 minus 102 minus 29, 49 degrees. Now we can do the law of sines to find the remaining sides that are missing. So I'm going to do the sine of angle 49 over its opposite side A equals the sine of 29 over its opposite side B, which is 28. To solve this, I just cross multiply, and I get 28 sine of 49 equals A sine of 29, and I can divide both sides by the sine of 29. All right, that solves for A, which A ends up being 43.6 feet. So I can write that right here. Then C is the other one I'm going to find. I'm going to do the same exact thing I just did, only now with C. So I'll go back up here and replace this relationship with C. So I'll put angle C here, which is 102, and I'll put side C here, and I'll solve the same exact way I just did. I'll cross multiply and get 28 sine of 102 equals A sine of 29. Divide both sides by the sine of 29. So it doesn't matter what you use as long as you stay consistent with the sine of one angle over its opposite side equals the sine of a different angle over its opposite side. In this case, A gives me 56.5 approximately, and that was feet. And I'm sorry, this was not A, this was C. I can't read my own handwriting. So this is C right here. Okay, the next thing is the toughest part about this assignment is that sometimes we're going to have situations where no triangle exists. Sometimes we're going to have situations where one triangle exists, and sometimes we'll have two triangles. And that is for only the case of when we're given side-side angle. Now in geometry we call this ASS, and we said we're not going to swear in math class, and we said that's not a triangle congruence theorem. If you remember, the triangle congruence theorems from geometry were side, 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 angle, side, angle, side, angle, 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 side, and HL congruence theorem was another one, which actually came from the side, side angle. I'll show you in a second. And what this one was when one triangle exists from this ambiguous case of side, side angle. So let me show you this. So here's all the situations we can have given side, side angle. So in this case, what we're given is this angle here, A, and we're given side B, and we're given side A. So we're given, angle, side, side. Okay. It turns out that there's all these different scenarios that can happen, and we're going to have to use reason and logic and critical thinking to determine which of these cases actually forms triangles, and then how many, because in some cases there's two. So let me show you these. For the first one, if you're given an acute triangle, so you're given an acute angle A, you're given side B. So let me give you an example here. Let's say that this is 30 degrees, and this side is 4, and this side is 1. This would be an example of this, where side A is less than the height of the triangle. In that case, what's going to happen is you're going to have no triangles because this side right here is not going to connect. Okay? Let's take a look at the next example then. If you're given an acute angle A, let's say 30 is an acute angle, and this time A equals H, so let's say that this is 3 and this is 4. So then in this case, this is the right triangle, and if you remember from geometry, this was the hypotenuse leg congruence theorem that you learned about. Okay, this turns out to be a right triangle because the altitude or the height is equal to side A here. So I guess I should actually, these numbers, in order to make them work, this would be 4, 3, and 5. There's an example of a right triangle. Okay, for the next case here then, A is greater than or equal to B, so let's say that we have an acute angle 30 again. This time this side's 4 and this side's 5. There is one triangle we can make there, so we're okay. We can use the law of sines in both of these cases, no problem, because there's one triangle. And you'll see, this will make more sense as we start doing homework problems. But the next case, there's two triangles. So when we have like an acute angle 30, for example, and the height is between A and B, so let's say that this is like 5 and this is like maybe 3, then when the height is between the length of A and, or I'm sorry, when A is between the length of the height and B, it turns out you can swing this side over, for example, and you can make two different triangles. So you can make this bigger triangle here, or you could make this triangle here with the same given information. So it turns out there's two triangles, in which case we have to give the information for both of those situations. Okay. The next example, there's no triangle that's made with an obtuse angle. So if I give you an obtuse angle like 100, and let's say this is 5 and this is 1, obviously this side doesn't connect, so there's no triangle that can be made. The last situation, I'm going to give you an obtuse angle like 120, and you know, say this is 3 and this is 5, or something like that, where this side is long enough to connect, then there's only one triangle, and we can use the law of sines just fine. So it turns out there's 3 cases where we can use the law of sines on. Actually 4, but this one we have to be careful because there's 2 triangles, and there's 2 situations where there's going to be no triangle formed. So we have to really think about this, and I'll show you what I'm talking about. So here's an example then. Let's say I have an acute angle here of 42, and this is 12, and this is 22. So we have to be careful about this, about how many triangles can be formed. Now the question is, can we move this leg down? Will it, you know, will it connect like over here somewhere and still be 22? Because there'd be 2 triangles in that case. It looks like there's only going to be one triangle. It looks like this falls into the situation of the third one here, where we have an acute angle and side A is bigger than side B, so there's only going to be one triangle. So we don't have to worry about 2 triangles in this case. But we do want to find the remaining sides and angles. So I'm going to use the law of sines. I'm going to do the sine of angle 42 over its opposite side 22 is equal to the sine of angle B over its opposite side 12. And I'm going to solve for the sine of angle B in this case. So multiply both sides by 12. And we get the sine of angle B equal about 0.365. And I can take the inverse sine then of the 0.365 to get the angle B, about 21.4. So now I can find this angle C up here by doing 180 minus these other 2, which gives me 116.6 degrees. And then I can find the last remaining information that I need, which is side C. So I'll do the sine of the 116.6 degrees over its opposite side C equals the sine of 21.4. Actually, I'll use the other one. I'll use A. That way there's no decimals here. Sine of 42 over 22. So just cross multiply and solve. So I have 22 sine of 116.6, which I'm going to leave in my calculator, equals C sine of 42, and divide both sides by the sine of 42. And you get side C, which in this case is 29.4, and that was inches. So that's this length of this side right here. So now I can list all those answers, and that I've solved the triangle for all the missing information. Okay, the last thing is area of an oblique triangle. It turns out that when we have a triangle like this that is not a right triangle, we can still find the area of it, and we're still going to use 1/2 base times the height. It's just that when we go to find the height, we have to be careful because we want to use, like for example in this triangle, the height would be opposite of our hypotenuse, so it'd be the sine of angle A equals opposite over hypotenuse. I can multiply both sides by b in this case, and it turns out the height here is b sine of A. So when I go to plug this in for the height here, what I get is 1/2 the length of the base, which is c in this case, and then the height, which is b sine of A. So my area formula changes basically because I want to find my height. So we're going to use a different, and this is the formula here. It's 1/2 bc sine of A, just like I wrote. It's basically the two sides and the angle in between. So whatever two sides you use, you want to use the angle in between. So here's an example then. Let's say we want to find the area of a triangular lot having two sides of length 90 and 52. What we can do, the angle in between them is 102 as well. We can use the formula 1/2 bc sine of A, which is on our formula sheet. So these are the two sides, 90 and 52, and the sine of the angle in between them is 102. We can solve 2,288.9 square meters. All right, so now you don't have to memorize this formula if you don't want, because you can always find the height by drawing this in. And or actually in this case I would draw this in. This would be the height, and I would use the sine of 102 equals opposite, which is the height, over 90. Multiply both sides by 90, and that's the way you can find the height, and use the formula 1/2 base times height, where the base is 52 and the height is 90 sine of 102, and that's exactly what we did here. So you're going to get the same answer. All right, let's try the homework and see if we can make this a little easier.